A new era of computing. Imagine a computer that doesn't just compute on silicon chips, but on the very atoms that make up the fabric of reality itself. A computer so powerful that it can solve problems in seconds, problems that would take today's supercomputers billions of years. This isn't science fiction. This is the promise of quantum computing, a technology that is evolving faster than anyone anticipated. But with this immense power comes a dire warning from renowned physicist Michio Kaku. Quantum computers are becoming so advanced that they may be capable of bending the very fabric of reality. According to Kaku, the arrival of quantum computers could be one of the most historic moments in human history, not just for technology, but for our understanding of the universe itself. But what does it mean for a machine to bend reality? And why should we be both excited and terrified by this possibility? In this deep dive, we'll explore the science, the speculation, and the staggering implications of quantum computing. Strap in. This is going to be a wild ride. The fascination with quantum technology. Quantum technology is the field of technologies in which quantum physics is actively utilized. That is, technologies that are only possible using quantum physical phenomena. These are typically phenomena such as superposition, where an object, such as an atom, can assume more than one value or be in more than one place at the same time, and entanglement, where an object, such as an atom, is physically separated from another atom, but where they are nevertheless connected, so that an impact of one atom will also affect the other. There are several reasons. What started the hype, and is in some way still driving it, is an algorithm for quantum computers that Peter Shor, an American mathematician and professor at MIT, developed in 1994. Shor's algorithm makes it possible for a powerful quantum computer to break RSA encryption. This is the encryption that is widely used when we send data on the internet. But there is also a clear assumption that quantum computers will eventually be able to handle many other calculations that are impossible using an ordinary computer. Therefore, a huge market potential is predicted for quantum computers. In other words, there is a lot of money to be made for those who can realize the quantum computer. And the hype is also partly due to the quantum computer being so difficult to develop and to its exploitation of quantum phenomena that are incomprehensible to many. The fascination with the technology itself contributes to the hype. Quantum computing has captured the imagination of scientists, tech enthusiasts, and even everyday people curious about the mysteries of the universe. At its core, quantum computing represents a radical departure from classical computing. While traditional computers rely on bits that are either 0 or 1, quantum computers use quantum bits, or qubits, which can exist in multiple states simultaneously, thanks to a phenomenon called superposition. This allows quantum computers to perform calculations at speeds that are unimaginable for classical machines. But it's not just about speed. Quantum computing taps into the strange and counterintuitive world of quantum mechanics, where particles can be in two places at once, where entanglement links particles across vast distances instantaneously, and where the act of observation can change the outcome of an experiment. These principles, which Albert Einstein famously called spooky action at a distance, are the foundation of quantum computing, and they're also the source of its mystique. The idea that quantum computers could rewrite reality, bend time, or even open doors to parallel universes has fueled countless stories, conspiracy theories, and speculative discussions. While some of these claims are rooted in genuine scientific curiosity, others veer into the realm of science fiction. But one thing is clear: quantum computing is no longer just a theoretical concept. It's a rapidly advancing technology with the potential to reshape our world in ways we're only beginning to understand. The science behind quantum computing. To understand why quantum computers are so revolutionary, let's start with the basics. Classical computers process information using bits, which can be either 0 or 1. These bits are the building blocks of all digital technology, from your smartphone to the most powerful supercomputers. But quantum computers operate on an entirely different principle. Instead of bits, they use qubits, which can exist in a superposition of states, meaning they can be 0, 1, or both at the same time. This ability to explore multiple states simultaneously gives quantum computers their extraordinary computational power. For example, a quantum computer with just 50 qubits can theoretically process more information than all the supercomputers on Earth combined. And when you add entanglement, a phenomenon where qubits become linked so that the state of one instantly influences the state of another, no matter the distance, you get a machine that can solve problems in ways that classical computers simply can't. But quantum computing isn't just about raw power. It's about solving problems that are currently beyond our reach. From breaking modern encryption to simulating complex molecular structures for drug discovery, quantum computers have the potential to revolutionize fields like cryptography, medicine, artificial intelligence, and even climate science. However, this power also comes with significant challenges. Qubits are incredibly fragile, prone to errors caused by even the slightest interference from their environment. This is why quantum computers require extreme conditions, such as temperatures near absolute zero, to function properly. The reality-bending potential of quantum computers. One of the most intriguing and controversial aspects of quantum computing is the idea that it could somehow bend reality. This notion stems from the strange and often misunderstood principles of quantum mechanics. For example, the concept of wave-particle duality suggests that particles can behave like both waves and particles depending on how they're observed. The collapse of the wave function, the idea that a quantum system exists in multiple states until it's measured, has led some to speculate that quantum computers could manipulate reality itself. Then there's the many worlds interpretation of quantum mechanics, which proposes that every possible outcome of a quantum event actually occurs, creating an infinite number of parallel universes. Some theorists have suggested that quantum computers, with their ability to explore multiple states simultaneously, might be tapping into these parallel realities. Could a powerful enough quantum computer actually shift us between timelines or rewrite history? While this idea is thrilling, most scientists agree that it's an oversimplification of the science. Quantum mechanics is undeniably strange, but it's also governed by well-defined rules. While quantum computers can perform calculations that seem almost magical, there's no evidence to suggest that they can alter the fundamental laws of physics or rewrite the past. That said, the cultural impact of these ideas is undeniable. From movies and TV shows to online forums and conspiracy theories, the idea of quantum computers bending reality has captured the public's imagination in a big way. The Mandela effect and quantum reality. One of the most popular theories linking quantum computing to reality bending is the Mandela effect. This phenomenon, named after the widespread false memory of Nelson Mandela dying in prison in the 1980s, he actually died in 2013, refers to instances where large groups of people remember events or details differently from what's recorded in official records. Some people have suggested that these discrepancies are evidence of quantum computers or other quantum phenomena altering our timeline. While this idea is fascinating, most scientists attribute the Mandela effect to psychological and social factors rather than quantum meddling. Memories are notoriously fallible, and the brain often fills in gaps with information that seems plausible but isn't accurate. The internet has amplified this effect, allowing false memories to spread and become widely accepted. Still, the Mandela effect remains a compelling cultural phenomenon that highlights our fascination with the idea of alternate realities and shifting timelines. The real-world impact of quantum computing. While quantum computers may not be rewriting history, they are poised to have a profound impact on the future. One of the most immediate concerns is cryptography. Modern encryption methods, such as RSA, rely on the fact that factoring large numbers is extremely difficult for classical computers. However, a powerful quantum computer running Shor's algorithm could break these encryption schemes in a matter of seconds. This has spurred a global race to develop post-quantum encryption methods that can withstand quantum attacks. Beyond cryptography, quantum computing has the potential to revolutionize fields like drug discovery, artificial intelligence, and climate science. By simulating molecular interactions at an atomic level, quantum computers could accelerate the development of new medicines. In AI, quantum algorithms could enable machines to process and analyze data on a scale that's currently impossible. And in climate science, quantum simulations could help us better understand and predict complex weather patterns and long-term climate changes. The race for quantum supremacy. The term quantum supremacy refers to the point at which a quantum computer can perform a task that's impossible for a classical computer. In 2019, Google made headlines when its Sycamore processor achieved quantum supremacy by solving a specialized problem in 200 seconds, a task that would have taken a classical supercomputer 10,000 years. While some critics argued that the problem was artificially crafted, there was no denying that Google's achievement marked a major milestone in the development of quantum computing. Since then, companies like IBM, Microsoft, and startups around the world have been racing to build more powerful quantum machines. Rumors of new chips like Google's Willow processor suggest that the pace of progress is only accelerating. But despite these advancements, practical quantum computers are still years, if not decades, away. The challenges of error correction, qubit stability, and scalability remain significant hurdles that must be overcome before quantum computing can become a mainstream technology. The cultural impact of quantum mechanics. Quantum mechanics has long been a source of fascination and inspiration for artists, writers, and filmmakers. From the multiverse theory to the